Okay, we're trying some more examples of computing values of the inverse trigonometric functions. And here we have to find the arctangents of the following common values. And so I'll start with my unit circle. And I remember that with arctangent, I'm always looking for values between negative pi over 2 and pi over 2, because arctangent is always between pi over 2 and negative pi over 2. I wrote less than or equal to there, but it should really be less than, because arctangent never actually hits negative pi over 2 or pi over 2. That's because tangent itself cannot be evaluated on pi over 2 or negative pi over 2, because you're basically trying to divide by 0 there. So I'm going to make a list here of x and arctan x. And root 3. Now, it's really useful if you can remember some common values of the tangent function. For example, tangent of pi over, let me start with tangent of 0 is 0. Tangent of pi over 6 is sine of pi over 6 divided by cosine of pi over 6, which works out to root 3 over 3. Tangent of pi over 4 is sine of pi over 4 divided by cosine. Well, they're both root 2 over 2, so it's 1. Tangent of pi over 3 is sine over cosine of pi over 3, so that's root 3. So that tells me what the values of tangent are at these common values, pi over 6, pi over 4, and pi over 3. There's another way to remember the values of the tangent function, which is to draw this line at x equals 1. And the tangent function is actually where these lines hit that line. So that's 1, that's root 3 over 3, and that's root 3. So if you kind of remember that, if you remember your common values of tangent, it's easy to figure out the values of arctangent. Let me start from the bottom because that's the easiest. Root 3 here. What angle has tangent root 3? Well, we just figured that out. That's pi over 3. Also, we get that from here. So pi over 3 is the angle that has tangent root 3. What angle has tangent 1? Well, there it is right there. It's pi over 4. What angle has tangent root 3 over 3? It's pi over 6. So I'm getting these from these common values over here. What angle has tangent 0? Well, that's 0. The negative ones are a little trickier, but if you just remember that the values in the fourth quadrant down here, they're just the negatives of the same values we had up in the first quadrant. So that's negative root 3, negative 1, and negative root 3 over 3. So for negative root 3, what's an angle that has that as its tangent? It's negative pi over 3. For negative 1, what's an angle that has that as its tangent? It's negative pi over 4. And finally, for negative root 3 over 3, what's an angle that has that as its tangent? It's negative pi over 6. So there's really two things that are key to being able to find arctangents. The first is knowing your tangents of the common values. And again, if you can't remember those, just remember that tangent is sine over cosine. And if you remember the sine and cosine of the common values, all comes back to those triangles. then you can figure out the tangents. It's good to remember the common values that you do get from tangent, namely root 3, 1, and root 3 over 3. So it's good to remember those numbers, but if you can't remember them, you can work them out from sine and cosine. Once you figure those out, then you can figure out the common values of tangent on the negative angles, and then you have to remember that arctangent always takes values between negative pi over 2 and pi over 2. So we're looking for angles between negative pi over 2 and pi over 2 that have the tangents that we've been given. So when we're given these tangents, we just remember values between negative pi over 2 and pi over 2 that have those particular tangents.